Hello everyone, I am Naman Srivastav and this is a presentation on Bitcoin evolution analytics, Twitter sentiment to predict price change as bearish or bullish. My co-authors are Omkar Gowda, Shreyas Bulbule, Siddharth Bhandari and Dr. Animesh Chaturvedi. We are from Indian Institute of Information Technology, Dharwad, India. So, motivation behind this study. Currently, there are over 100 million people who own Bitcoin and the total value of this asset is more than 300 billion US dollars. However, this market is extremely volatile. We have seen the price of a single Bitcoin go up and down by thousands of dollars in a single day. So, where does Twitter comes in? Social media platforms like Twitter can provide us with information about what people are saying, what they are thinking, and what their sentiments are. For entities like Bitcoin that are difficult to assign a fixed value, it is possible that they are heavily influenced by the sentiments of their investors. So these sentiments can be gathered from Bitcoin, from Twitter, and from the tweets that people do about Bitcoin. However, not all of these tweets have same effect on the value of the currency. So in this study, we aim to answer three research questions. First is how to predict the price change with binary classes, bearish or bullish, using sentiments in tweet. Next is the user sentiment. It is a term that we have coined, which will be described in further presentation. Is this a better measure to predict Bitcoin price compared to just a sentiment analysis score? Next is what are the machine learning models which give the highest accuracy and F1 scores for predicting price change when we consider sentiments, the followers of a user, and the technical indicators of Bitcoin as well.
Hello, this is Dr. Animesh Chaturvedi. I'm going to discuss about system evolution analytics. That is the motivation behind this work. So at the different evolving systems are there, like Bitcoin itself is a kind of uh, evolving system that at the state SI at the time point TI could be represented with an evolution representative. And this makes a state series of state S1, S2 up to Sn for different time point T1, T2 up to Tn. These works are being published at IEEE Computer Society conferences and IEEE transaction and journals. So getting motivated from there, we made Bitcoin state series as a collection of states that could be represented as S1, S2 up to Sn plus 1 at various time points. That makes Bitcoin data set 1, Bitcoin data set 2 up to Bitcoin data set n plus 1. So we use this Bitcoin state series to form a Bitcoin data set like this. For each timestamp for a state, we made user sentiment score for Vader positive, Vader negative, Vader neutral, Vader compound. We also used BERT to calculate user sentiment score. We also calculated polarity, subjectivity. Then we used three different technical indicator like error down, error up, ADL. For each of these uh, state, after 1 hour, we calculated whether there's an increase of price, it's bullish, or there's a decrease of price, means bearish. So we have done analysis for per hour basis. For example, after the closing price, we calculated whether it's bearish or bullish in per hour basis. So in a day, there are 24 hours that will make 24 BTDs. And in 7 days, it will make 7 cross 24 time points or BTDs. So we have done 13-month analysis. So you can assume that there is large number of states or BTDs are there. So big number of BTDs are there to study. So then each of this Bitcoin had made Bitcoin state series, and that will use to create some Bitcoin data set. We want to study relationship between the features as well as the price, bearish or bullish. Then this each of the price is being labeled as bearish and bullish that we have discussed. This has been given features and labels have been given for training. the supervised Bitcoin evolution learning models, that the good features will actually contribute to overall improvement of accuracy and F measure. We used 27 different machine learning models for analysis. So average could be like accuracy and then average number of models that been used, and F measures average is also been calculated. Then next part was being presented by Siddharth Bhandari.
So yeah, hello everyone. I am Siddharth Bhandari and I will be explaining the basic framework that we have used for predicting the price change as bearish or bullish using the tweet pre-processing. So what we did is we have collected the historical tweets from the Twitter, and thereby we did the spam filtering, and spam filtering is done using TF-IDF vectorization and random forest. Thereby we have processed our data using regular expression. So let me tell you a brief overview about how we pre-process all the tweets. So firstly, we have collected the original tweets, and thereby we removed the hyperlinks that were in that, and converting that text into the lowercase. And at the same time, we were removing the punctuation, symbols, and numbers, as well as the additional spaces. So that's how the tweets are pre-processed. And moreover, after the tweet pre-processing, we have done the sentiment analysis using three tools, that is Pinbot, Vader, and TextBlob. So these are the three tools that we have used to extract the sentiment score. And the main feature of our research is the user weighted sentiment. That is, the sentiment score that we have derived is multiplied by the number of followers that that user possesses. And these all information are collected in a data frame. Parallelly, we have collected the historical data using the crypto compare API, and we have fused these two together to form the Bitcoin state series. Now, after this, we have labeled the state series for supervised learning, and we have trained 27 machine learning models, and those models are used to compare the accuracy as well as creating the test sets. And that's how we have came up with an idea to predict the price change either as bearish or bullish. Now, let me tell you the overall input that we have used to create the Bitcoin state series. From BERT, we have collected a score that is called BERT score. And from Vader, we have four inputs that are Vader negative, Vader neutral, Vader positive, and Vader compound. And from text blob, we have two parameters, two input features, that are text blob polarity and the text blob subjectivity. So these seven were the sentiment score that are input to our Bitcoin state series. And there are three indicators, technical indicators, that are associated with it are Arun down, Arun up, and accumulation distributive line. Moreover, we have also given the input of Bitcoin price at Bitcoin closing price at that time. So all these features are the input for the Bitcoin state series. And for that after the state series is created, we have trained 27 machine learning models and performed ensemble learning. And that's how we have predicted the price change as bearish or bullish. Now, let me tell you the thing that is most related to the conference of big data and how our data is called the big data. So basically, there are 5 V's that are associated with the big data. That includes volume, velocity, variety, veracity, and value. So let me explain you point-wise how our data is called the big data, that is the Bitcoin data. So volume. So our data consists of 9,000 plus states that has been created after fusing millions of tweets together. And that's how we have got the Bitcoin state series, which contains 9,000 plus states. Velocity. Our data consists of an enormous amount of data as to understand the market sentiment that is associated when the Bitcoin tweets are generated. Variety. Our data set consists of variety of features. Like we have got 7 features from the sentiment analysis, which we have derived from 3 tools, that is Finbot, Vader, and TextBlob. And from the technical indicators, we have got three features that are Arun up, Arun down, and accumulation distributive line. So this variety of features we have in our data set. Veracity. Our data is completely raw and it is collected from the Twitter API called Tweepy. Value. Our data set consists enormous amount of value for the purpose of investment. As many people are interested in the investment for the Bitcoin as a future asset, they can use this data to predict the market sentiment and can have the investment and can set the investment strategies accordingly to gain profits from Bitcoin. Thank you.
Hello everyone, this is Shreyas Bulbule and I will explain you about the features that we are using in our Bitcoin prediction models. So first, we will talk about sentiment features. So we have FinBERT, which is the BERT model but trained on a large financial data corpus. So this BERT model, which is a very popular model, which stands as bidirectional encoding encoder representations transformers. So this model gives output for BERT label and BERT score. This model was purposefully trained on financial data, and then FinBERT was formed, and that we are using for extracting this features, which is BERT level and BERT score. BERT level simply labels the sentiment as positive or negative, and then we have BERT score, which gives the intensity of the positivity or the negativity found in the tweet. Then we have Vader, which is valence aware dictionary sentiment analysis. So it gives us 4 outcomes. Again, this feature has been selected because this feature is known for giving good outcomes for social media texts, and since Twitter is social media, we have used it. So it gives 4 outcomes: negative value, positive value, neutral value, and compound value. Negative, positive, and neutral value respectively tells us about the negativity, positivity, and neutrality present in the sentiment, and then the compound value just combines all these variables and gives a general value. And then we are having user sentiment. So this feature has been included in some of the data set that we have trained. This has been included because we wanted to see that how influential people like give an effect on the uh, trend, in the future trend of the Bitcoin. So as into number of followers the user who has tweeted. So in this way, the person who is having more followers, that is the person who is more influential, his sentiment would be more weighted than a person who has less followers, and hence is a less influencer, is a smaller influencer. So here S can be any numerical score of sentiment extracting algorithms. So just now we saw the FinBERT and BERT. It could be the BERT score, the negative value, positive value, neutral value, and compound value. Actually, we have used all of them as after we used all of this sentiment features and then multiplied them by the number of followers number of followers the user who has tweeted, and this thus we get the variable as user sentiment, and we have used it for predicting the next hour's Bitcoin price trend. So now we'll move to the technical indicators. So we are exploring the combination of sentiment analysis, sentiment indicators, and technical indicators. So we are exploring these 2 indicators. So first of all, Arun up and Arun down. So this popular indicator was proposed by a popular technical analyst, Mr. Tushar S. Chande. He has this feature helps in identifying upcoming trend and also the magnitude of the trend. So it basically calculates, it is built on calculating the 25 number of days after the 25 period high or low. So it is actually built on the idea that the strong uptrends and downtrends are supposed to reach new highs and new lows, and therefore this feature has been included because it talks about trends, and it takes into account the past like how the Bitcoin's price has been fluctuating and how the trend is going on in the past. That's why we have taken this feature into account. Similarly, accumulation distribution line is another feature which is volume based, and it predicts trend between the assets price and volume flow. As you can see, it is calculated by this formula. It also takes in account the closing and the uh, closing price, the highest price and the lowest price in a timestamp t. And after collecting all this data for a single moment of time, we combine all the data for 1 hour by taking average of all the features, all the values we got, and in this way one state of the Bitcoin state series is formed. And that's it from my end. Thank you.
Hello everyone, I am Omkar. So we have used ensemble techniques that aim at improving the accuracy of the results in models by combining multiple models instead of using a single model. The combined models increase the accuracy of the results significantly. In our work, we have used six ensemble techniques for the experimentation, which are hard voting, random forest bagging, which also stands for bootstrap aggregation, AdaBoost, which stands for adaptive boosting, gradient boosting, and extreme gradient boosting. We have trained 27 models on the same training dataset. These models were trained using the default parameters set in scikit-learn. We further perform hyperparameter tuning on the ensemble learning models. The accuracy and F measure obtained for each model are then recorded and plotted. So we observed that the accuracy achieved was higher when considering the user sentiment scores. The highest accuracy achieved when using the sentiment score was 62%. The average accuracy and F measure for all the models trained were around 43% and 33% respectively. On the other hand, when we use the state series formed using user sentiment scores, the highest accuracy achieved was 53%, which is less than the highest accuracy achieved in the previous case. But however, the average accuracy for all the models trained was 52%, and the average F measure was 48%. On the other hand, tuning of the hyperparameters, the highest F measure we obtained was 69.5%, and the accuracy we obtained was almost 61%. Okay, so on including the technical indicators, in the state series, we observe that the highest accuracy achieved is around 63%, and the average of all the models is 51%. And the average F score is around 49%, which is an improvement in an overall performance. So as we can see that if we use only sentiment scores, we get an average accuracy of around 43.36%. and average F measure of 33%. While if we use user sentiment scores and technical indicators, we see an increase in accuracy, which is around 52.6%, and an increase in F measure, which is around 51%. And if we look at the max of among the 27 models that we have trained, we get 69.5%, which is in the gradient boosting model. For the conclusion, we introduced Bitcoin evolution analytics, which uses Bitcoin state series to predict Bitcoin price change in the next hour as bearish or bullish. We found that user sentiment scores is a better predictor than sentiment scores. We also found that gradient boosting model performed the best. Also, the combination of technical indicators and sentiment indicators perform better than only sentiments. For the future work, in future work, we plan to extend Bitcoin evolution analytics to retrieve various system properties like system network complexity, system stability, and changeability. The Bitcoin evolution analytics would also be helpful in evolution recommendation by constructing a system neural network. Thank you. If any questions, you can mail to us at our respective emails